Welcome to the BOSCH Virtual Driving Center. Here we use computer simulations of a variety of driving situations to continuously further develop automotive technology. In 1976, BOSCH introduced the first lambda oxygen sensor. With more than 400 million lambda sensors produced to date, BOSCH is now the undisputed market leader. Incredible! A chain of all the lambda sensors BOSCH has produced would be long enough to connect all our lambda sensor production sites worldwide twice over. A milestone in air cleaning, the LSU wideband lambda sensor. Another state-of-the-art BOSCH innovation for today's automobile. The lambda closed-loop control with LSU has several advantages. Lower system costs, reduced fuel consumption, improved drivability, and compliance with current and future emission standards, and diagnosis regulations. True, LSU unit costs are higher than for conventional switching type sensors, but the overall system costs for exhaust gas aftertreatment are lower. I'll show you why. First of all, there's the continuous lambda control, which would be impossible without the LSU's highly accurate and dynamic response. The LSU measures even the slightest deviations in the AF mixture quickly and accurately. That means that the closed-loop lambda control corrects the deviations before they adversely affect the catalytic converter's performance. Thus, smaller catalytic converters can be installed, which results in reduced noble metal coating costs. Further savings can be made with the help of cylinder individual lambda control, also made possible by the LSU sensor. Due to deviations in cylinder charges and tolerance of injection valves, the exhaust gas mixture varies in the different cylinders. Because the LSU continuously measures the exhaust gas stream, it's able to detect deviations in the mixture formation for the individual cylinders. This reduces the extra costs involved in achieving mixture uniformity. In no time at all, the engine management system equalizes individual cylinder lambda deviations. The conversion rate of the first catalytic converter is increased by the more homogeneous exhaust gas composition. As a result, the noble metal coating of the catalytic converters can be further reduced. But that's not all. The secondary air diagnosis with the LSU provides further savings potential in overall system costs. It complies with the stricter requirements for onboard diagnosis without extra sensors. The LSU's high accuracy greatly improves the catalytic converter diagnosis, making the system more robust. Better use can be made of the diagnosis limits than before, allowing for further savings in the exhaust system, especially when it comes to catalytic converters. The bottom line is that the LSU can reduce the overall cost of the exhaust gas treatment system by about 20%, by lowering the cost of some components and eliminating others, decreasing the amount of noble metals used. With the LSU, compliance with current and projected future emissions regulations is no problem. Furthermore, our wideband sensor LSU can also detect and selectively control AF mixture enrichment and enleanment, which supports catalyst purging, engine warm-up, and component protection, among many other things. The result, reduced fuel consumption and improved engine performance, as only the exact amount of fuel required is always injected, even outside the engine's stoichiometric operating points. Amazing, actually, what a little LSU sensor like this can achieve throughout the entire service life of the vehicle.
BOSCH. Invented for life.